Oh, 3.5. I'll have to see. I'll check on that in a second. Okay. So first off, we're going to find the roots here. So we just factor using the box. We stick in the x squared and the negative 12. Multiply those together. Negative 12x squared. Are there factors of negative 12 that add to be negative 1? That would be negative 4x and 3x. So I put those in the remaining two boxes. Pull out an x. And I get x minus 4. And then x plus 3. So my factors are x minus 4 and x plus 3. And to find the roots, I just write equals 0 and solve. So the first one is 4. And then negative 3. Okay. So here is a quadratic, and it turns out it doesn't factor. Well, actually it might. But it's telling us to use the quadratic formula. So this should be a review from last year. The quadratic formula is right here. If you forget it, negative b plus or minus the square root of b squared minus 4ac over 2a. And a is the first number, the first coefficient, b is the second, and c is the third, as long as the quadratic is put in order. So if the quadratic is out of order, if it's spread on both sides of the equal sign, then you need to move everything to one side to use the quadratic formula. So the instructions say, do the opposite of b. So negative 9 turns into 9, plus or minus the square root. And then you have to be careful with your b squared. If you type in negative 9 squared in your calculator, you're going to get 81, or negative 81. But what is negative 9 times itself? Positive 81. So why does this give me the wrong answer? Yeah, order of operations says we do exponents before we do subtraction. So the calculator thinks that you want the opposite of 9 squared instead of the square of negative 9. So if you're going to put negative numbers in your calculator, make sure you put parentheses around it. Or just don't. Just do 9 squared and you get 81. Okay, and then I recommend writing this piece out together. Negative 4 times negative 4 times 4 times negative 1. Negative 4 times 4 is negative 16. Negative 16 times 1, negative 1 is 16. So we add 16. And then we divide by 2a, which is 8. So that gives me 9 plus or minus the square root of 97 over 8. What goes into 97? I think it's prime. Does 7 go into 97? I think 97 is prime. Either way, it's not going to simplify. So you would put your answers as 9 plus the square root of 97 over 8, or 9 minus the square root of 97 over 8. But what if instead of 97 we had 84? How do you simplify the square root of 84? So we factor it. So 4 and 21, 2 and 2, 3 and 7. Does anything come out? A set of 2's. So we write a 2 outside, and then a 21 stays inside. So this would be 9 plus or minus 2 square root of 21 over 8. Okay. Now, one thing you need to check to see is, do these have anything in common? And in this case, they don't. But what if I had 6 plus or minus 4 root 10 over 8? So everything in that problem is divisible by 2. But you're not allowed to simplify the inside of the square root with something that's not under a square root. But these 3 all share a 2. So I can remove a 2 from those 3 numbers. So it would be 3 plus or minus 2 root 10 over 4. And notice I didn't touch the 10. You cannot simplify something inside the square root with something that's outside the square root. Okay. Here we're going to go backwards. We have a quadratic, and we know that it hits the x-axis at -5 and at 3. We also know that its leading coefficient is 5. So we want to build a quadratic equation that meets those 3 characteristics. So if one of the roots is -5, what factor created that root? So if x equals -5, what factor created that root? What would the factor look like? X plus 5. And all we're doing is getting a 0 over here. So we add 5 to both sides. And I get x plus 5 equals 0. Okay. Similarly, what factor created x equals 3? X minus 3. Now I multiply those together. So you can distribute this way, or you can use the multiplication box, whatever you prefer. And you're going to end up with x squared plus 2x minus 15. So I have just met this qualification and this qualification, but it says that the leading coefficient needs to be a 5. Multiply the entire equation by 5. Uh-oh, she's on her phone. Oh, calculator. Good job. So, that's not a calculator. Let me see. Let's see. Not a calculator. Oh my goodness, that's okay. First 2 are free. Minus 75. There we go. So 5x squared plus 10x minus 75. Okay, last problem. Okay, we want to find a polynomial that has those 5 numbers as roots. So what would the factor be that creates x equals -9? X plus 9. And the next one, x minus 3. Ooh, what about 0? We could say x plus 0, or that's also known as x. So x minus 2, and then x minus 1. So that polynomial, you could multiply together and get a big long x to the 5th, but we don't want to do that. We'll just leave it in that form. If you type that into your calculator and graph it, then it will hit the x-axis at -9, 3, 0, 2, and 1. Okay, that's it. Get to work.